Hi guys, this is going to cover 8.1 and 8.2. We're going to talk about functions. So, when we are talking about functions, what do we mean? We're going to be talking about, is something a function? What is the domain of the function and what is the range of the function? The domain of a function is all, very hard for me to write and talk at the same time, all possible x values of a function. The range is all possible y values. A function is an equation where every input, every x, has only one output, but your output is your y. So every x only has one y, all right? Your domain is your x, your range is your y, okay? I'm gonna make a little table up here. Maybe down here. So when we're talking about x and y values, right, you might have a 5 here and a 3 here. That's the point 5, 3. You can plot it on a graph, right? A line on a graph is just a bunch of those points that are so close together that they connect into a line. The line goes on forever. That's a function. That's something you can graph, right? So your x values, think about it like this, okay? But your x values are also your domain. Your y values are your range, okay? So I'm going to call x my domain. I'm going to call y my range. What else did I say up here? I also said every in has only one out. X is my input. Y is my output. Okay? When I put in a value for x, I can find the value for y, the output, right? Domain, range, input, output. There's another, we can call it the independent variable and the dependent variable. Okay. A good way to remember whether it's x is the domain or the range, alphabetically, x comes before y, d comes before r, and I comes before O, right? I doesn't come before D. So independent just means we put in the x, right? X is the input. The output depends on the input, okay? So just alphabetically, I think x comes before y, d comes before r, I comes before O. If you're trying to decide, is the domain the x or is the domain the y? Is the output the x or is the output the y? The output is after the input, the dependent is after the independent variable, okay? So we're talking about a graph often, or we might just be talking about a set of points. It might be in graph form, right? You could just plot all of those points. It might be in table form, or it might be in a mapping. So this mapping is the domain is -9, -9 maps to -16, okay? So it could be in a mapping, it could be in a graph, it could be in a table, or it could be in a set of points. Good? So for a function, every input has only one output. Remember when we saw y equals 3x? And then we also might have seen somewhere earlier in this course, f of x equals. If y equals 3x is in fact a function, we can call it f of x equals 3x, okay? So y is a function of x. If I put in 5 for x, y becomes 15. If I put in 5 for x, f of x becomes 15. All right. Even, one second. It is even possible to graph these, right? Y equals, let's do 12. Let's do 1/4 x plus 9. Good. F of x same thing. Okay, so is it a function or not? If it's a function, you can say y equals 3x, or you can say f of x equals 3x. All right. For it to be a function, every input has only one output. What I want you to think of is the input. This is how I think of it. X can only have one y. If I put in 5 here, I'm only ever going to get out 15, right? I'm not going to put 5 in here, and sometimes I get 15, sometimes I get 10 as my answer, right? So my input is an item at the grocery store, right? So if I take my item up to the grocery store, my apple, all right, it's one apple. If I take my apple up to the self-checkout at the grocery store, it should always cost $1. Sorry, the dollar sign goes on the other side of the one, right? It's okay if the apple and the banana both cost $1, but I shouldn't be able to take that same apple up to a self-checkout and sometimes it's $1 and sometimes it's $5, okay? It's okay if we have 5 apples all still cost $1, right? Or 4 apples still cost $1. That's okay, right? 5 is something I'm buying, it costs $1. 4 is something I'm buying, it costs $1. That's still a function. However, what I can't have, and that would not be a function, is sometimes I take that 5 up to the register and it costs $1. Sometimes I take that 5 up to the register and it costs $20. Okay, the price of the item, this is the item, the price shouldn't change. Okay, a bunch of different things in the store can have the same price, but the price of the item is the 5 shouldn't change prices each time I go up to the self-checkout. All right, that's how I think of it. So the domain is the item, the range is the cost of the item, just in terms of every input can only have one output. Every item can only have one price. It's okay if everything in the store, because it's the dollar store, costs $1, but I don't want to take this 5 up to the counter. Sometimes it's $1, sometimes it's $20, sometimes it's $13. Okay, so let's look at, this is just a series of points, right? The domain are x values, or our inputs, or our independent variable, okay? The domain is the x values. When you're looking at a point, we've looked at this before, okay? This guy is just saying, here's the relation, okay? That's all he's doing. Saying this is the beginning of the relation, this is the end of the relation, here's the relation, okay? All functions are relations, not all relations are functions. So here's a function. And, well, I guess a function is all of these, right? We're making a group. And they fall within the group of relation. Every function is a relation, kind of like how every square is a shape. Or you could say even a rectangle, right? Every square is a shape, but not every shape is a square. You also will have a box for circles, a box for triangles, okay? So all functions are relations, not all relations are functions. Determine the domain of the relation, determine the range of the relation. Remember, domain is your x value, range is your y value. So I just highlighted it with some random color. My domain is my x value. My x value for the first point is -3. Second point is 1. Third point is -9, 4, -1. So my domain is How should I write it? Hold on. I'm going to write it, including those brackets that we started with. Okay, so those same brackets get the beginning of the domain. Now, -3, I'm just going to put a comma, list your next one. 1, -9, 4, -1. If it repeated and you had 3, 1, -9, 4, -1, 1, you wouldn't need to write that second 1 again. That's the domain. Okay, now let's look at the range. The range are my y values. -4, 6, -8, -6, 9. So my range is -4, 6, -8, -6, 9. Good? All right. We determined the domain of the relation. We determined the range of the relation. That's all you're doing. You're just making a list because all they gave you was a list of points. You pick out the x's, those go in the domain. You pick out the y's, they go in the range. Doing the same thing here. So again, we have brackets. Okay. This is just because this is pink doesn't mean it's a function. Just mistakenly used the same color to highlight two different things. So remember, our domain are our x values. So I'm going to say it's -4. Here's another -4. I don't need to write it twice. 9, 5, 8. That is my domain. I already included the -4 with the 6, so I don't need to write the -4 a second time. For the range, we're talking about our y values. We have the value of, 6, -9, +9, -7, and 3. There's the range of my relation. There's the domain of my relation, okay? Remember, for a function, every x has only one y. All right, here, let's just notice, here we have a -4 and then another -4. However, this -4 has, when I input -4 into the equation, this time the equation gave me 6. When I input -4 into the equation again, it gave me a -9. That means it is not a function, okay? Not a function, because -4 should only have one y value. It should always be the same, okay? So if they wanted to write -4, 6, if they wrote -4, they should write a 6 again, okay? They didn't, so it's not a function. Here, this is just called a mapping. A mapping can be interpreted as a bunch of points, right? So 1 mapped to -15 is just 1, -15. -6 mapped to 15 is -6. +15, -16, -7. Good. It is possible that you also see this just as a bunch of points on the graph, okay? If all they're giving you are points on the graph, you should still be able to find the domain and the range, okay? The domain, if we start down here with the green, just on the leftmost, the first domain point is -16, next one's -6, and then number 1. And then the range is going to be -7, 15, -15, okay? Now they're not asking us to find the domain and the range. They gave us the domain. The domain is 1, -6, -16. The range is -15, 15, -7. They're just asking us, is this a function? Is this a function? Yes. Each domain is not repeated, right? If it's not repeated, it's going to be a function. This wasn't a function because it was repeated with different y values, okay? X does not repeat, right? My domain, each domain is unique. That's another way to say it, okay? Here is another mapping. This mapping is a little different because in this mapping, we just had this point mapped, one arrow went straight to -15. -6 mapped straight to +15, -16 mapped straight to -7. What does it mean if A now maps to X, B now maps to X and to Y, and then C maps to Z, right? If I was going to make a table, okay, just like this is a set of points, I can also turn it into a table. The table would be 1, -15, -6, 15, -16, -7. Okay? The table is just an X, Y value table. Okay? Here, if we were to make a table of these values, we need to take into account that B maps to both X and Z. What would that look like? The first one would be A maps to X. B now gets two different rows. Column, row. B now gets two different rows. So it doesn't just go A, B, C like we see on the mapping. It goes A, B, B, C. All right. A maps to X, B maps to X, B also maps to Y, and C maps to Z. This is not a function because just like right down here, we had -4 mapped to 6 and -4 mapped to -9. Here we have B mapping to both X and Y. That means I have two B's. When I take this B up to the cash register at the store, sometimes the price is X. When I take that same B, because it's the same B, up to the cash register, sometimes it's Y. That is not a function. Each X is, what should we say? That each X is not mapped to a unique Y. I can say each X is not mapped to only one Y, okay? We can also say B has more than one output value. Domain B has more than one range value. Or a range value. Okay. Number 6, -9 maps to -16, -6 maps to -16, and -15 maps to -16. So if I was to make a table, this is the mapping, but the table would be -9 to -16, -6 to -16, and -15 to -16. All right, we haven't seen this before, right? We've seen a domain with two ranges, a domain with two different ranges. We haven't seen a range with three different domains. This is still a function. Each X is mapped to only one Y. Each domain is only mapped to one range. Each X is mapped to only one Y. It's okay that the Y is not mapped to a unique X, right? That this has three different X values. Maybe we're at the dollar store. -9 is worth the same amount as -6 as -15. What we don't want is for -9 to cost -16. Sometimes -9 costs 20, okay? Each X is mapped to only one Y, so it is a function. It is okay if your Y repeats. It is not okay if your X repeats. This is a problem, not a function. This is not a problem. This is okay. Number 7, let me get back to my black because there are too many colors. All right, this is a table, but it's a table that's just sideways, okay? Compared to the tables I've been making. My XY tables that I should label as XY tables. Good? So, X of -2 maps to 3, 1 maps to 9, 5 maps to -2, 7 maps to 3, 12 maps to 3. Is it a function? Those are all unique y values. Or sorry, unique x values. All x values are unique. That is the same as saying x does not repeat. Okay? X does not repeat is the same as each x is mapped to only one y, or all x values are unique. Those are all ways to say that I'm not seeing x repeat with different y's. X does not repeat at all. You can say that. Each x is mapped to one y, or all x values are unique. You're saying the exact same thing, okay? Now let's look at this one. X of -6, y is 5. -6, y is 1. This is just like this problem, okay? -6 maps to 5, -6 maps to 1. So we're going to say this is not a function. Why? -6 has two different y values. I didn't even keep looking, right? I stopped there. -6 should only ever be 5. It should never be -6, 5 and -6, 1. Okay? These guys, we're looking at them the same way we're looking at these. Okay? My domain is -2. My range is -1. My domain is 1. My range is -6. My domain is 5. My range is -1. My domain is 8. My range is -9. My domain is 11. My range is 8. Good? Let's just look at that again. -2, 1, 5, 8, 11. Function yes. Why? X does not repeat. It's okay that y repeats. All right, let's look at these numbers. Let's look at number 7 and let's look at number 8 if those points were graphed, okay? So I'm just going to take my XY table and say that this -2, 3 becomes a point x -2, y 3. All right, what does that look like? It just looks like this. So here's -2, 3, here's 1, 9, here's 5, -2, here's 7, 3, and here's 12, 3. That's everything that they gave us on that table. And then they want to say, is this a function? Now, that if we zoom in, we see that -2, 3, 7, 3, and 12, 3 are all on the same horizontal line, right? But we said 7 is a function. That is because there are no x values with the same y value. So this x value is -2, the purple one. The black one, the x value is 1. The red one, the x value is 5. The blue one, the x value is 7, and then the green one, the x value is 12. Those are all unique x values, so those are all put together. If they are put together as a relation, that relation is a function. It's okay that there is a horizontal line that would go between -2, 3, 7, 3, and 12, 3, okay? However, let's look at 8 now. This was question 8, and what we see is an x value of negative, so if we start from left to right, we have an x value of -6, 5, and we have an x value of -6, 1. Here's the problem, okay? So when x is -6, y is at the same time 1 and 5. That's the problem, okay? I'm going to go back to the other graph now. If y is 3, that's okay. Y being 3 multiple times, 1, 2, 3 times, that's okay. Going back to the other graph, x being -6 2 different times is not okay. It is okay that when x is 1, it only touches 1.3, but here, because x at -6 touches both -6, 5 and -6, 1, that makes it not a function. So if you're just looking at the graph and points on the graph, or even like a line on the graph, if there are two places where a horizontal line will intersect that graph, it is not a function, okay? All right. Number 10, is this a function? Why or why not? So we've got -7, -3, 1, and 3. They do not repeat, so it is a function. X values do not repeat. Good. Then we've got 7, 1, 6, 11, 1. I have a repeating X value with a different Y value. If I were to graph that at X equals 1, I would have 1, 7, and I would have 1, -8, not a function. Okay. What is the vertical line test? The vertical line test is exactly this. If I draw a vertical line on a relation, I should not intersect that relation more than once. Okay. When finding domain from a graph, when finding domain from a graph, you look left to right. Domain is all your X values, right? Horizontal along the X axis, okay? For range, you look not right to left, you look down. I'm just going to say down to up. Good. So if we were to look back at, even if it's not a line, right? Well, that's a line, but this isn't a line. This is just a group of points. And we're saying, what is the domain? The domain is from left to right. The domain is -6, 1, 4, 7. Don't worry about repeating, okay? The range down to up. So the range is going to be -4, 1, 3, 5, 6. Okay? So we're just going to say how far on the x-axis does it go to find the domain? How far on the y-axis does it go to find the range? Okay? Now they only give us a picture of a graph and ask, is this a function? Okay, remember, does it pass the vertical line test? So I take a vertical line like this ruler and I put it across the picture, okay, across the graph of the relation. If there's anywhere I can draw a line, a vertical line, and it intersects that function in more than one place, it's not a function. But as long as it only touches the graph in one place, it's a function. So is this a function? Yes. Okay. Just to compare, a circle is not a function because if I pass the vertical line test, there are many, many places, and you only need one place, but there are many, many places where it touches the graph 2 times, okay? And just to show you again, we decided that this set of points was not a function because if I say my vertical line is right here, it passes through that relation in 2 places, okay? Doesn't matter that right next to it at x equals -5, it doesn't pass it anywhere. If there's one spot on the graph that it passes through the relation 2 times, it's not a function. All right, so it looks like this is a function. My domain, this is impossible to see. All right, I'm going to assume that this arrow goes on forever, okay? If your arrow goes on forever, it's a line that goes on forever because, look at this. Let me just make something up here, okay? It's not x equals -6. Now it's y equals x plus 1, okay? Get rid of all these guys. Hope I don't regret that later. It goes on forever. Okay. So when we're looking at a graph, we're often looking at a line that goes on forever in both directions, continues in this way forever. Okay. So that's why I'm going to assume that this has arrows. So the domain, if you're looking at the domain of this and there's an arrow, so remember, domain is from left to right. So beginning at my leftmost point of the graph, where do I see my domain begin? I see it begin here, but I see that there's an arrow here. So my domain is from infinity. It starts at negative infinity. And then where do I see it? I see it in an arrow in the other direction, in the positive x direction. So it goes on to infinity. So my domain is from negative infinity to infinity. And then my range, remember, we're looking from the bottom to the top. Here it is at the bottom, but it's going forever towards the bottom or towards negative infinity. And then at the top, the arrow is going up, so that's towards positive infinity. Because of the arrows that go even ever so slightly in the negative x direction and the positive x direction, they go forever, so that domain is negative infinity to infinity. Same with the range. The range is easier to see because the arrows are really pointing up and down, but ever so slightly, they're also pointing right and left. So eventually, infinity is forever. Eventually, it's going to go forever in the negative and positive direction in the x-axis as well. Okay, so if it has arrows and both of those arrows go in opposite directions on the x-axis, it's negative infinity to infinity. If those arrows go in opposite directions on the y-axis, it's negative infinity to infinity on the y-axis as well for the range. Here, we're not going to say that it is, oh, sorry, interval notation is what we're working in, okay? We're not, here, a line is just points. There are so many points that they become a line, okay? That's what a point is. That's what a line is, sorry. A line is just a bunch of points. This isn't a line. These are just points, okay? So for the domain, we're just going to say, oh, it's gonna take forever, I'm gonna pause it. All right, pause it so that I could find those points. So this one's this, 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 okay? So those are my points. Now, the domain is going to be, how do they want me to write? I think we're going to write it the way we were writing it on that first page of notes. So we're going to go like this for both the domain and the range, okay? All right, just start from left to right. The domain is -4, 1, -1, 0, and 1, okay? You don't need to include the two different ones. I see the two different ones, but you don't need to include them in your answer, okay? Sorry, you can see that. Now my range is 0, -1, 1. Oh, sorry. Let's look at my x values. Start that over. My range is -3, 2, oh, that's supposed to be a -2. Yeah, that go. -1, 2. No, that's good. 2. Okay. -3, -2, 2, 3, 4. That's my range. Is it a function? Is it a function? It is not a function because 1 on the domain maps to both the 3 and the -2. Okay. Here, domain. So I'm going to find the domain and the range first, and then I'm going to say, is it a function? The domain is on the x-axis. So remember, domain, left to right. So from left to right, I see an arrow going in the left direction. So that means it starts at -infinity. I keep going. I see an arrow going ever so slightly in the right direction. So that's towards infinity, right? So on my x-axis, do I see something going forever like that, then that's negative infinity. And if I see an arrow going forever like this, then that's positive infinity. So even though it's going much further down than across, it's going across. Even though this is going further down than across, it's still going across. So that is still negative infinity to infinity. Okay, I just want to make that clear. It doesn't matter how slightly, if it's an arrow and it's going in the negative x direction, it's negative infinity. If there's an arrow going in the positive x direction, that's positive infinity. Okay. Range, however, is y values. So for my y values, I do see negative infinity, right? However, both of those are going in the negative y direction. So you need to see where we get to the top. I'm going to call it 6. Did you say that's 5 or 6? Good. I'm going to call it 6, yeah? So from negative infinity to 6 on my y value, okay? Is it a function? Well, I don't see any place, if I was to do the vertical line test, I don't see any place where I would cross the graph of the relation twice, so it is a function. No x values have more than one y value. 17 we already looked at. This is not a function because there are many, many, many places on this graph where you can find an x value with a y value of 0, for example, and an x value with a y value of -5. So this would be 3, 0 maybe, and 3, -5. So that would be not a function. The domain from x to y, or sorry, from negative x to positive x, I'm going to call it from 1 until 5. Hopefully your graphs are way better than mine. And then my range is going to be from, remember, start at the negative side. So -5 to 0. Okay. So from -5 to 0 on my y, from 1 to 5 on my x, but not a function. Here, again, I'm going to add the arrows. My domain, it does not start. It does not start at negative infinity, right? There's no arrow towards negative infinity, no matter how slightly. It starts at -2. I'm very much just guessing. It's hard to see. It's a tiny, tiny graph. Good. But it does go forever in the positive infinity direction. Okay. My range from -y, I see an arrow going in the negative y direction, so that's negative infinity, and then I see an arrow going in the positive y direction, so that's positive infinity. Is it a function? It is not a function, because if I use my vertical line test, I can find many places where a vertical line will cross that graph in more than one place. Good. All right, 19. This is a function, right? Let's switch it up a bit. It is a function because even though it's swirling, it's curving, it's not going back on itself like the circle or the sideways parabola. So it is a function. There's no place where I can put a vertical line that will give me 2 y values for 1 x, okay? My domain from -x to +x is from negative infinity to infinity. My range on the y, remember we're starting at the bottom, -5, to the top of, oh, is that a -1? Yeah, sorry. -1 to +1. I just can't read the font, it's too small. Good. So it's going to go up and down, up and down, up and down, but it never goes above +1. It never goes below -1. And even though these are arrows, the arrow implies in this way forever. So it's not an arrow that's suddenly going to just start going straight down. It's going to continue the pattern it's already shown us. Okay. 20, is this a function? Yes, no matter how many vertical lines I draw, I will never cross this graph in more than one place. So this is a function. the domain, negative infinity to infinity on the x-axis, and then on the y-axis, it only exists at 7, I think. Good. All lines except vertical lines are functions. This line is a function. That line's not straight, so that's not a line. That is a circle. That's a curved line, but that line is a function. Okay, that's what they mean by that. Now, the form of functional notation is if something is a function, instead of y, we can call it f of x. When the value of y, what is the value of y when x equals whatever is inside the parentheses? Okay. All right, guys, I need to go back. I need to go back to all of these. I apologize. Let's start at number 14. All right. I was not doing interval notation. So I started with interval notation because with negative and positive infinity, it's just parentheses, and this one's okay because it's just a grouping. However, here it ends at 6, but it includes 6. So instead of parentheses, it needs to be a bracket. Okay, my fault. Here, it's going to be a bracket because it includes 1 and it includes 5. It includes -5 and it includes 0. It includes -2 and goes till infinity. And then it includes -1 and it includes 1. Okay, so if you're ending on a number, you're going to use the bracket. I apologize. And then 7, in fact, would just be this guy as though it were a single point instead of a line. Okay, so my notation was not great. So f of x equals means that it's a function, and we can replace y with f of x, okay? Explain the following common misconception about functional notation. So, given f of x equals x minus 4, find f of 2. What they're asking is, what is y when x equals whatever is inside of the f of x? Oh, sorry, okay. F of x equals y. Here, f of x equals x minus 4. F of 2 means what is the value of all of this when x becomes whatever's inside the parentheses. So f of x equals x minus 4. F of 2, 100% of the time, okay? 100% of the time, what they want you to do is take that 2 and put it here. Okay, you're just substituting in that number for the x and finding your answer. So f of 2 is -2. Good. F of 0, when f of x equals x squared plus 5x minus 4, all we're going to do is say f of 0 equals, instead of x squared, we're going to put in a 0 squared, because anywhere we have an x, we're now going to put a 0. Plus 5 doesn't change, but x becomes 0 minus 4. Okay, I know we're skipping around, but f of 0 equals 0 squared is 0, 5 times 0 is 0. F of 0 equals -4. Okay, how is this true? Because 0, -4 is a point on this graph. 0 is my x, right? And then -4 is my answer. 0 is my input, right? It started with f of 0 equals. So that means 0 became my x. That's why it's up here. 0 became my input. When I input 0 into it, I got -4 as my output, or -4 as my y value. So I'm just going to call it, I'm going to type in this equation, f of x equals x squared plus 5x minus 4, and we will see that That point is on the graph of the line, okay? There are other points on the graph of the line, but when I put in 0 for my x value, the only y value that comes out is a -4, okay? F of 0 equals -4 because the point 0 for my x, when my x equals 0, my y will equal -4, and so the point 0, -4 exists on that line of the function, okay? So when we say f of x equals something, and you see it get replaced with a number, that just means put that number in for x, all right? So why would this happen? F of x equals x minus 4, find f of 2. F of 2 equals 2 times x minus 4 equals 2x minus 8. No, right? We're not multiplying everything by 2. We're just saying x becomes 2. Okay? Find the function value. We have f is our function. All right, we can call it f of x, or we can just call it the function f. F -6 means x is -6. Just like f of 2 means x equals -2. F of -6 means x is -6. When x is -6, what is y? When x is -6, y is 15. Good. F of x equals y. What is f of 3? When x is 3, y is 5. F of 3 is 5. F of 0, when f of x equals x squared plus 5x minus 4, because when I put 0 in for x, what do I get for y? I get -4 for y. Find f of -4 when f of x equals x squared minus 2x minus 2. Same thing. Instead of being f of x now, it's f of -4, -4 squared minus 2 times -4 minus 2. So all I did was changed all of those x's to -4s. Nothing needs to change about the notation. Remember, f of x is just equal to, f of x is just equal to y. So nothing needs to change about that notation. That's just like saying y equals, okay? So nothing ever happens on this side. This side just tells us what to put in for x, okay? Now, if we're careful, -4 squared, -4 times -4 is a positive 16. This is now -2 times -4 is going to be a positive 8 minus 2. 16 and 8 becomes 24. Minus 2 is 22. Let's see if my addition is correct. So we will get rid of that guy. I said the point f of -4 equals 22. So that means my x is -4. And when my x is -4, my y is 22. That's what we decided, right? F of -4 equals 22 means I think that the point -4x, 22y, I think that when x is -4, y equals 22. So I believe -4, 22 is a point on that graph, because when x is -4, y will always be 22. So I've labeled the point -4, 22 right there. And now I'm going to input my original equation. You can either call it y equals x squared minus 2x minus 2. Or you can call it f of x equals x squared minus 2x minus 2. Same graph, okay? And negative 422 is on the graph. We can even make a table. When x is negative 4, y is 22. Okay? Find f of 19 when f of x equals the absolute value of x minus 13. F of 19 equals the absolute value of 19 minus 13. F of 19 equals the absolute value of 6, which is 6. Again, you can check it on your graph. The absolute value of x minus 13 implicit equation. All right, x minus 13 equals y, and is the point when x is 19, y is positive 6. Is that on the graph? Good. So f of 19 equals 6. F of negative 4 equals 22. Good. Find f of a when f of x equals x squared minus 18. All you can do here is now it's a. So instead of x squared, it's a squared minus 18. Use the graph of y equals f of x to find the function value. Good. Sounds confusing. Don't worry. Okay. All right. I added the points. I tried to label the points, but f of 3 equals is just like asking us when x equals 3, what is y? Okay, so x equals 3 is going to be on 1, 2, 3, right? What point is on the x equals 3 line? 3, negative 4. This guy. Okay, so f of 3 equals negative 4. F of 0 is just asking when x equals 0, what is y? When x equals 0, y equals 0. I missed that point. F of 0 equals 0. Good. F of negative 4, when x equals negative 4, what is y? Way over here at negative 4, y is negative 2. So f of negative 4 is negative 2. Good. Here we have f of 4 equals, so when x is positive 4, what is y? When x is all the way over here at positive 4, what is y? Y is 2. Good. Write part A as an ordered pair. So an ordered pair is just saying, instead of f of 3 equals negative 4, x is 3, y is negative 4. Okay? F of 0 is 0. That's the ordered pair. 0, 0. F of negative 4 equals negative 2. That's just the ordered pair. Oh, sorry, I'm doing all of them. -4, -2. F of 4 equals 2 is just the ordered pair 4, 2. Yeah, because those match up. 3, -4, 0, 0, 4, -2, 4, 2. Oh, sorry, -4, -2, 4, 2. All right. So now, what are the values of x if you're only given f of x? F of x equals 4, opposite question. So if we say f of 3 equals, it's when x is 3, what is y? F of x equals 4 when, think about it, pause the video, when y equals 4, what is x? Okay, and we're still looking at the same graph. And here it is when y equals -4, what is x? Okay, so it's not a mystery like I need to make up an equation here. I have it right here. F of x equals -4, right? F of 3 equals -4 means y equals -4. When y equals -4, what is 3? X is, or sorry, what is x? X is 3. When y equals -4, here's my y. When y is down at -4, oh, not that one, that's -3. That's the graph's fault, not mine. When y equals -4, x is 3. When y equals 4, what is x? So when y is way up here at 4, x is -3. How do we write that? Sorry. X is -3 when y is 4. So the point was the ordered pair was -3, 4. F of x equals 4. F of -3 equals 4. And over here we had what, when y equals -4, what is x? X is 3. So we have 3, -4, or the point f of, sorry, the function f of 3 equals -4. All right, and that is it for today. Thanks so much, guys.